Hello everyone and welcome back. In this lesson, we will be finding the nth term of an arithmetic sequence that is in quadratic form. Our objectives will take us through examining those progressions or sequences and use different techniques to find the nth term when they are quadratic. Let us remind ourselves what an arithmetic sequence or progression is. A sequence is arithmetic if the difference of any two consecutive terms is constant, and that is when we take two consecutive terms and subtract them, an plus 1 minus an, we end up with d, and d is what we call the common difference. Each term in our sequence is found by adding the same real number, d, that is adding the common difference to our previous term to get the next term. So whenever we want a new term, we add the common difference to the term that we have. Now, we use a table of differences to find what that common difference is. So let us start by using a simple sequence, which is a set of odd numbers, 1, 3, 5, 7. Now, the common difference here, 3 take away 1 is 2. 7 take away 5 is 2. This is our first difference. Our first difference, let me just write it as 1st. First difference, and the first difference here is 2. Once we only have one line of differences, it's telling us that our sequence is linear in nature. That is, it is of some form un equal to an plus c. Let's try the table of differences on this sequence. So we have 5, 10, 17, 26, 37. Notice here that when we do the table of differences, 10 take away 5 is 5, 17 take away 10 is 7, 26 take away 17 is 9, then 11. That when we do the first difference, we do not get a constant number. However, when we do the second difference, 7 take away 5, we end up with a number that is constant. Now notice that we had to do two sets of subtraction here. First we subtracted to get the first difference, and then we did a subtraction on the first difference to get the second difference. And that is when we found the table, the constant. So this would tell us that this is x to the 1 and this is x to the 2. So this particular sequence is quadratic in nature and would follow a form that looks like this. Un is equal to an squared plus bn plus c. Let's talk a little bit more about that. So consider this sequence generated by the formula un is equal to n squared plus n. So this particular formula is generating these numbers for n equal 1, 2, 3, etc. So when we substitute 1 for n here, we get 1 squared plus 1, which is 2. Substitute 2, we get 2 squared, which is 4 plus 2. Here we get 6, etc., etc. So these are the values that it puts out for that domain. When we do the first difference, we get 4, 6, 8, 10, 12. So here in the first difference, we do not see a constant. But when we do the second difference here, 6 take away 4 gives us 2, 8 take away 6, etc. We notice that we have the same number here in the second row. Again, when it's like this, we know that it's quadratic because it has 2. This would be x, and then followed up by x squared. Or in our case, n squared. So remember, a quadratic sequence would follow this particular rule. Un is equal to an squared plus bn plus c, where a, b, and c are constants. And our job is to see how can we find this particular thing. All right, let's try it. Now, the first way that we're going to use is to use simultaneous equations. The first method we're using, rather, is to try simultaneous equations. Now, this is the general form of what we're looking for. Remember, this is the answer, and this is what we're working toward. So we can use simultaneous equations by substituting 1, 2, 3, etc. into this equation to make simultaneous equations. So let's go. Suppose we substitute 1 in here, then we're going to get 1 squared, which is 1. So we have 1a plus 1b plus c. So our first term, when we substitute 1, would be a plus b plus c. And of course, we know that our first term is equal to 2. If we substitute 2, then we're going to get here 2 2's 4, 4a plus 2b plus c, and the second term in the sequence is 6. Also again, if we substitute 3, then we're going to get 9a here plus 3b plus c, and the third term is 12. Now we can work with these three equations and using the process of elimination end up with the formula that we need that gives us this answer. So first, notice that you have three letters. And generally, when we're solving simultaneous equations, we want to make sure that we have two letters so we can eliminate one and to get the answer for the other one. But here we have three, and that is why we have three different equations. So we're going to combine these two first, and then combine these two. Now we're going to try to eliminate the c out of this one. So if we do that, subtracting these two equations, 4a take away a, let's just write it down here first. 4a plus 2b plus c, notice that's equal to 6, and a plus b plus c is equal to 2. Notice we have three letters, as I said, and what we want to do is reduce it down so we can end up with 2, so we can solve them easily. So we're going to start first by getting rid of the c. That looks like the easier thing to do. So 4a take away a gives us 3a here. 2b take away b gives us b here, that's plus b, and that's equal to 6 take away 2, that's 4. All right. And then we can combine these two to say 9a plus 3b plus c is equal to 12, and 4a plus 2b plus c is equal to 6. And subtracting these two, 9 take away 4 here gives us 5a plus 3 take away 2 here is 1b, and the c is eliminated, and that gives us 6. So we have two equations here. We have that equation and this equation here where we have eliminated the c from both. Now we can solve these two equations together by writing them as 5a plus b gives us 6, and 3a plus b gives us 4. So we're going to eliminate again. Notice here, the b's are the same, so we can just subtract them. So 5a take away 3a gives us 2a, and 6 take away 4 gives us 2. So 2a is equal to 2, and that tells us immediately that a is equal to 1. Since we know that a is equal to 1, then let me just use another ink here. Then 5a plus b equals 6. That tells us that 5 times 1 plus b is equal to 6. So 5 plus b equals 6. And that means that b is equal to 1 as well. Now we need to find c. A plus b plus c is 2. And substituting these, a is 1, b is 1, plus c, which we don't know yet. So 2 plus c is equal to 2, and that means that c is equal to 0. Once we have done that, we can substitute these values a, b, c into this general form, and we get our result. So let's write it in. Un, therefore, would be equal to 1a squared, not a square rather, 1n squared plus b is 1, 1n plus 0. And notice that this is the same thing as this. It's just a matter of writing it a little more elegantly as writing it as un is equal to n squared plus n. So we can use simultaneous equations by substituting 1, 2, 3, 4, etc. into the general form, get our equations, and solve those simultaneous equations to find what our general term would be for our sequence. That's one way. Admittedly, it takes a little bit of work So solving simultaneous equations is quite possible, and yes, it's long, but it's doable. The question though is there another way? And yes, there is another way if we pay attention to the table of differences. Now let's say we substitute into the equation un. Remember, that's what it is. Un is equal to an square plus bn plus c. Now when we substitute 1 into this, we end up with a plus b plus c. As we saw it earlier, when we substituted 1, we got this. Substituted 2, we got this. Substituted 3, that's what we got here. So substituting 1, we get a plus b plus c. Substituting 2, we get 4a plus 2b plus c. And substituting 3 and 4, we get these. Now, what happens if we use these instead of using the actual terms that we had in the sequence? So if we write these out, first term, second term, third term, fourth term, and do the first difference, then what we get here is here, 3a plus b. Here, 5a plus b, 7a plus b. So you begin to notice 3, 5, 7. And then when we do the second difference, 5a plus b minus 3a plus b gives us just 2a. Same thing here. So the second difference is 2a. The first difference is 3a plus b. And the first term is a plus b plus c. And this is dealing with the first term in the sequence. So the first term is a plus b plus c. The first difference is 3a plus b, and the second difference is 2a. Let's use that. So the first difference is 3a plus b, the second difference is 2a, and the first term is a plus b plus c. Now this is our sequence. This is a set of triangular numbers. And let's see if we can use this particular formula rather than using the simultaneous equations to find the nth term. Remember, the nth term has the form un is equal to an square plus bn plus c. But here now, let's look at our table of differences. So we have 1, 3, 6, 10, 15, 21. The first set of difference here is 2, then 6 take away 3 is 3, 10 take away 6 is 4, so we notice that it's going that way, 2, 3, 4, 5, 6. And then the second difference would be 1. So this is the first difference, and this is the second difference. Now, according to our formula here, or our observations here, our second difference is equal to this. So using this particular line here, 2a would be equal to 1. And that means that a is equal to 1 over 2, or a half. Now, the first difference here, 3a plus b, is going to be equal to here, 2. So 3a plus b is equal to 2. We already know what a is. A is a half. So 3 times a half plus b gives us 2, which means that 1.5 plus b is equal to 2. And that, of course, means that b is also a half. And what about our c? The first term, a plus b plus c, is equal to, in the sequence, 1. And so we can write it out as a is a half, b is a half, plus c equal 1. Now half plus half is 1, so 1 plus c is equal to 1, which means here that c is 0. And so we can write out our sequence in this form. Un would be equal to half n square plus b is also a half n, and c is 0. And we could factor this out and make it look a little prettier by saying un is equal to half n square plus n, or of course you could write it in another form by saying un is equal to half n into n plus 1. And this would be the general form of our triangular number. So if you want to find any particular triangular number, say you want to find the 20th triangular number, then you would put 20 here, half of 20 into 20 plus 1. So half, so u20 would be equal to half of 20 into 20 plus 1. For argument's sake, half of 20 is 10. And 10 times 21, that would give us 210. And we can use this formula to generate any triangular number that we want. Seems pretty easy. Seems a lot easier than using the simultaneous equations. Let's try it again. This time, we're going to use this sequence, 13, 24, 39, 58. Now, first we want to look at the table of differences. So 13, 24, 39, 58. At first time, when we subtract them, we end up here with 11. 24 from 39 gives us 15. And then the other one here gives us 19. This is the first difference. And when we do our second difference, 15 minus 11 is 4. We end up with our second difference. So we can use these values along with the formula that we used earlier, the method that we used earlier. So 2a, from this, 2a is going to be equal to 4, and that tells us that a is equal to 4 divided by 2, which is 2. The next term is going to be 3a plus b, and 3a plus b is going to be equal to 11. So 3a plus b gives us 11. A is 2, so 3 times 2 plus b is equal to 11. That means 6 plus b is 11. And of course, that tells us that b is 5. And then the first term, a plus b plus c is equal to 13. Now, we know that a is 2 plus b is 5 plus c is equal to 13. So 7 plus c is equal to 13, and that tells us that c is equal to 13, take away 7, which is 6. So we have found our values, and having found our values, we can write them in the general form un is equal to an squared, putting our a is 2, so it's 2n squared, plus bn, b is 5, 5n, plus c is 6 in this case. And so this sequence, this is a particularly ugly 6. Let me just write that a little better. There we go. Not much better, but a little bit. And so this sequence here, algebraically, is described by the formula un is equal to 2n squared plus 5n plus 6. And so we can find the nth term of a quadratic sequence. It's an arithmetic sequence, quadratic in nature. We can find the nth term by using simultaneous equations, or we can use this particular observation to work it out. Whichever seems easier to you, that's what will work for you. Either method will work. That's it for now. Remember to get some practice to tie down the skills. And of course, remember, you can use your calculator, generate sequences, investigate them, and generally have a lot of fun with your sequences. If you haven't subscribed yet, please do so. Thank you for watching, and I hope you would have learned how to find the nth term of an arithmetic sequence that is quadratic.